Natural tantalum consists of two stable isotopes, 181 Ta and 180 Mta. The latter nuclide 180 Mta has sufficient energy to decay in three ways: isomeric transition to the ground state of 180 Ta, beta decay to 180 W, and electron capture to 180 HF. However, no radioactivity from any decay mode of this nuclear isomer has ever been observed. Only a lower limit on its half-life of over 10–15 years has been set, by observation. The very slow decay of 180 Mta is attributed to its high spin and the low spin of low-lying states. Gamma or beta decay would require many units of angular momentum to be removed in a single step, so that the process would be very slow. The very unusual nature of 180 Mta is that the ground state of this isotope is less stable than the isomer. The same property is exhibited in americium 242 meters. 180 Ta has a half-life of only 8 hours. 180 Mta is the only naturally occurring nuclear isomer. It is also the rarest primordial nuclide in the universe observed for any element that has any stable isotopes. There are also 35 known artificial radioisotopes, the longest-lived of which are 179 Ta with a half-life of 1.82 years. 182 Ta with a half-life of 114.43 days, 183 Ta with a half-life of 5.1 days, and 177 Ta with a half-life of 56.56 hours. All other isotopes have half-lives under a day, most under an hour. There are also numerous isomers, the most stable of which is 178 meters 1 Ta with a half-life of 2.36 hours. Tantalum has been proposed as a salting material for nuclear weapons. A jacket of 181 Ta, irradiated by the intense high-energy neutron flux from an exploding thermonuclear weapon, would transmute into the radioactive isotope 182 Ta with a half-life of 114.43 days and produce approximately 1.12 MeV of gamma radiation, significantly increasing the radioactivity of the weapon's fallout for several months. Such a weapon is not known to have ever been built, tested, or used. Tantalum has a relative atomic mass of 180.94788. Table. Abbreviations. EC. Electron capture IT. Isomeric transition. Bold for stable isotopes. Bold italics for nearly stable isotopes. Only known observationally stable nuclear isomers believed to decay by isomeric transition to 180 Ta, beta- decay to 180 W, or electron capture to 180 HF with a half-life over 1.2 times 10–15 years. Believed to undergo alpha decay to 177 Lu. Notes: values marked hash are not purely derived from experimental data, but at least partly from systematic trends. Spins with weak assignment arguments are enclosed in parentheses. Uncertainties are given in concise form in parentheses after the corresponding last digits.